Hello, my dear friends. Welcome to my channel, Math and Stuff uh, with Samson Paul. Today is the third video and probably one of the first videos where I'll be going in order to start with differentiation. Okay, we will go in order to start with differentiation, and today, that is at this moment, I'm going to discuss with you a formula on how to derive various formulas using first principles, that is differentiation using first principles, right? And this is one of the formulas, general formulas you could say, for differentiation. If you want to derive the derivative of a function f of x, then the function f of x is nothing but function f of x is nothing but limit, okay, you can see limit h tends to 0, okay, f of x plus h minus f of x by h, okay. And please note that h is a small increment. How small? Very small increment, okay, very small increment. And you can also express it. If let us say you have y, you have let me use color blue, you have y as a function of x given here, so you can also say y dash of x or dy by dx, okay. Differentiated with respect to x is nothing but y dash limit delta x tends to 0, okay, y x plus delta x minus y by x minus y of x divided by delta x. All right, and it is important to note that h here and delta x here are same. They are not similar, they are just same, they are different representations, okay. And also delta x, basically delta means a very small quantity or small increment or small quantity, whatever you want to call it. You can, if you're comfortable with using f of x, you can use f of x. If you are comfortable with using f dash of x or y dash of x, you can use f dash of x. I'm sorry, if you're comfortable with using f dash of x, you can use f dash of x. If you're comfortable with using y dash of x, you can use y dash of x. All right. Based on this, we are quickly going to derive one of the formulas. Okay, one of the formulas, and that formula is nothing but y equal to f of sin x. Y equal to f of sin x. Now, if you were to memorize, you already know that if y is sin x, dy by dx is cos x. You already know that, okay. But I am going to show you how did we derive this formula. There are many ways to derive the formula, but how did we derive this formula using the first principle method, also called as FMP. I use FMP with my students, first principle method, okay. So the general formula is, okay, let me remind you the general formula again, okay. I'll remind you the general formula here. Y dash of x or simply y dash is equal to limit h tends to 0, okay, f of x plus h minus f of x divided by h, okay, divided by h Okay, this is the formula, right? So there is, I think there's an error here. It has somehow noted it has kind of a bracket, but that's okay. What it means is basically f of x. Okay, f of x. Now coming back to the formula, you can see here I have put that in the formula. Y dash of x or f dash of x is limit. You can write limit LT or LIM, one and the same, delta x, or in this case I'm going to use h. Please use whichever you're comfortable with, delta x or h. H tends to 0. So now your function is sin x plus h minus sin x by h. All right. And to further solve this entire equation, I would say you need to apply a formula, a trigonometric identity, and that trigonometric identity is given right here. Sin a minus sin b is equal to 2 cos a plus b by 2 sin a minus b by 2. This is one of the trigonometric identities. These identities are also called as conversion formulas. Okay, these identities are also called as conversion formulas. Why they are called as conversion formulas is because you are converting subtraction or addition of trigonometric functions into division or multiplication. Okay, that's why they are called as conversion formulas. Sin a minus sin b is equal to 2 cos a plus b by 2 sin a minus b by 2. Basically what it means is I have successfully converted sin a minus sin b into multiplication formula. 2 sin a plus b by 2 multiplied by sin a minus b by 2, where a plus b by 2 is inside the bracket. So this whole thing is inside the bracket, and this whole thing also is inside the bracket. Now please remember that this entire thing is always in radians. A minus b by 2 or a plus b by 2 is always in radians. You cannot operate differentiation functions on degrees. You have to write equivalent of radians, then you can operate the function. Okay, so always it is must to have cos of theta radians or a plus b radians. So here in this case it is in radians. Now I will apply that formula to my, if you see here, I'll apply that formula to my step shown here on the top, and when I apply that formula I get sin x plus h is nothing but sin x plus h minus sin x is nothing but 2 cos x plus h by 2. Okay, that is this function up plus x by 2 minus x plus h minus x by 2, because of the reason that x plus h is a and x, that is the second function, is b. Okay, this is a and this is b, right? So we can further simplify. You can say that x plus x is nothing but 2x, and 2x divided by 2, if I'll get x plus h by 2. Okay, and x and x minus x will get cancelled and I'll get sin h by 2. Okay, now the formula above equation, the limit equation y dash basically becomes this equation here. Okay, it becomes this equation here. Okay, y dash is equal to limit h tends to 0, 2 cos x plus h by 2 sin h by 2 by h. Okay, and y dash, now what I am going to do is I am going to try to arrange in such a way that I am comfortable with. And I'm going to tell you in a minute why I'm going to do that. So we have a general limit, okay, a general limit which exists in limits and continuity. The general limit is limit theta tending to 0, theta tending to 0, okay, theta tending to 0, sine theta by theta, sine of theta by theta, and this limit is nothing but 1. Even though it seems to be 0, if you directly supply 0, sine 0 by 0, you'll get it as 0. Even though it seems to be 0, it is not 0, it is 1. Okay, this is one of the limits that has been solved. Probably in one of the classes I would solve this limit, how we get this, but for today you have to just remember this limit, that is limit theta tends to 0, sine theta by theta is equal to 1. Now in place of theta here I have nothing but h by 2. Okay, in place of theta I have nothing but h by 2. Okay, I'm going to reduce the size of my highlighter. It is h by 2 here. Okay, so I have to have another h by 2 to balance this out. So what I'm going to do is, I already have a h in the denominator. I'm going to get this 2, okay, down here. Okay, I'm going to get this 2 down here, and that way I'm going to express my y dash as limit h tends to 0 cos x plus h by 2 sine h by 2, sine of h by 2 divided by h by 2. Now what I'm trying to tell you is that this entire function h by 2 is theta. Okay, this entire function h by 2 is theta. Okay, also you have to remember, since this function is operating in trigonometry, okay, h is actually in radians, okay, because it is an angle. So h by 2 also will be in radians. So there won't be any confusion whether it is a number or something else, because since sine is there, and sine can operate only on angles that are in radians, or for convenience you can also take sometimes in degrees, but sine can only operate on angles, so you can be sure that h is also a small change in the angle. So there's no confusion there. So it is definitely just h by 2 is definitely just theta. Okay, we will go further. We will go a little bit further using this, and when we do that, what we do is we apply the limits. Okay, we apply the limits, and we apply the limits. When we apply the limits, we see that cos x plus h by 2. Okay, now directly apply the limit in this case. Okay, directly apply the limit. Okay, so I will, before I kind of try to evaluate this limit, I will give you a general rule. So if you have limit, okay, if you have, let me use a different colored pen so that is pretty clear. Limit x tending to some value, let's say x tending to some value a. Okay, you have f of x. Okay, you have f of x, and you also have multiplied by g of x. Then this can be expressed as limit x tends to a, f of x into limit x tends to a g of x. Okay, this is one of the formulas which might come in handy. So if you have a function that is multiplied, you can actually evaluate the limit separately. Okay, and that is what I am trying to do here. I am trying to kind of evaluate the limit separately. Okay, so I have stated that here. I have stated that here. Let me see. I have stated that I have stated that here. Okay, here I have stated that I'm directly going to apply this limit. Okay, and when I apply that limit, my x will not change. Okay, my x, which is here, will not change. Okay, but my h will change to 0 because I have a limit h tends to 0. My h will tend to 0. So 0 by 2 is 0. So cos of okay, cos of x plus 0 is nothing but cos x, and that is what I have got here. Okay, and for the second function we have this limit theta tends to 0, sine theta by theta is 1 radians, and that is the limit I have applied here. Limit h tends to 0, sine h by 2 by h by 2 is equal to 1. Okay, substituting back everything back in this equation here, let us call this say 1. Substituting everything in 1, you get the value of this limit here is nothing but 1, nothing but cos x, and the value of this limit here is nothing but 1, and you get f dash of x or y dash of x is equal to sin x. Okay, so let us quickly understand it one more time. I am going to quickly kind of review it. Here is that if I have y equal to sin x, okay, then y dash is sine of, okay, y dash is limit h tends to 0, or even I can say dy by dx, because y is a function of x, and sine x plus h minus sin x divided by h, and this is equal to cos x. Okay, this is my answer. Okay, this is a simple solution. Okay, you can similarly try the formula for y equal to cos x. You can try the formula for y equal to cos x. Okay, and you should get y dash is equal to limit h tends to 0, okay, cos of x plus h minus cos x divided by h, okay, and you will get minus sin x here. Okay, you can verify this. Only thing you have to do is you have to apply formula cos a minus b, cos a minus cos b formula. You should be applying this formula. Please, I'm not going to give the answer away. Please find out what this is. Okay, it will come in terms of some trigonometric functions, either sine or cos. I'm not going to give the answer away. And try to do it in a similar manner, and you should get a negative sign. All right, I hope you understood and enjoyed this class. I hope you enjoy mathematics. Have a good day. Bye.